Let's move on and talk about lightning-related injuries. In order to understand injuries related to lightning, we need to have a basic understanding of what lightning is. It's essentially an electrical discharge between two areas of imbalance. When a cumulonimbus cloud forms during a storm, it tends to cover a large distance of altitude, as shown in the picture to the right. Within the cloud, water gets caught in an updraft and collides with downfalling ice and graupel. Graupel is semi-frozen particles. These collisions shear off electrons, thus creating an electrical imbalance. When those charges build, they eventually overcome the insulating properties of the atmosphere, and the charges are released in the form of lightning. And as you can see from the areas of differing electrical charge, a lightning strike can occur within a cloud, between two clouds, or between the cloud and the ground. This is based on the current theory of lightning. Globally, there are about 240,000 lightning strikes per year. 400 of those occur within the United States. Now, it's estimated that 10% of all strikes result in death, which equals about 24,000 deaths per year, 40 of those occurring within the United States. Some other statistics are that most lightning strikes occur in rural areas, and most lightning strikes occur in Africa. Looking at this graph here, it's interesting to note that as the lightning strike mortality declined, it correlated with the migration from more rural to more urban living. This is thought to be due to the fact that in rural environments you have an increased occupational exposure to lightning strikes because you're outside doing things such as farming and herding, but also because there tends to be a lack of access to protective shelter during lightning strikes. Now, this is just a correlation because other experts believe that other factors such as better storm warning systems and increased public awareness have also helped to decrease lightning mortality. This is lightning strike data obtained from 1995 to 2014. And as you can see, in the center of Africa, you have not only dark but gray areas correlating with extremely high density of lightning flashes. Looking at data that's been obtained a little more closely, we see that Zimbabwe has a very high death rate in one study. And looking at South Africa, we can see the disparity between rural death rates and urban death rates. Moving on to the United States, most common lightning strike areas are in Texas and Florida, and most lightning strike victims are male between the months of May and September. In the United States, we do have a lightning detection network known as the National Lightning Detection Network. It relies on a combination of ground detection as well as satellite data to give us this information. Using data obtained from 2007 to 2016, you can see that there's a pretty high density of lightning flashes per square mile in the Florida, Louisiana, and Texas regions. But there are also high rates in Oklahoma, Kansas, and Arkansas. In addition to a national lightning detection network, there are personal detection devices available commercially. These work by detecting the electromagnetic pulse from the lightning. This is similar to how you might hear a pop when listening to an AM radio during a storm. And though they try to, they are really not very good at detecting distance, the path of the storm, the location of the strike, and these are subject to interference from other objects, such as appliances or cars. How it attempts to detect the distance of a strike is based on the strength of the electromagnetic pulse. But using this assumes that all lightnings have a uniform electromagnetic pulse strength, which is not the true case. So while these may give you a general idea that a lightning strike has occurred, it won't tell you much more than that. As with most things in life, prevention is key. When thunder roars, go indoors. After that, you need to wait 30 minutes after you hear the last thunder. It used to be a 30-30 rule, meaning that if you saw lightning and heard thunder, within 30 seconds you needed to seek shelter. But now it's anytime you hear thunder, you should begin to take preventative measures. When seeking shelter, look for particular objects. Find the largest enclosed building, stay clear of any doors or windows. You can go into a standard metal top car. It'll create a sort of Faraday cage. You can go inside a dense forest or a deep ravine. What you want to avoid are isolated trees, shallow caves, open shelters, and tents. And then obviously avoid very tall objects such as cell towers and ski lifts. Being aware of signs of an impending lightning storm is also important for prevention. Darkening skies, building cumulonimbus clouds, and increasing winds can all indicate an impending storm. Cumulonimbus clouds will create the typical anvil-style cloud that we saw earlier in the slides. These can help result in those electrical forces needed for lightning to occur. If you're in a group and you're unable to find adequate shelter, it's important to separate more than 20 feet. It's believed that lightning can jump 15 feet, so separating by 20 feet should prevent more than one member in the party being injured if a lightning strike should occur. Because overall, it's better to have just one injured party member than 12. In mountain environments, lightning is most likely to occur in the afternoon, so the old saying is up by noon and down by 2. You want to be coming off of the peak by 2 o'clock in the afternoon. Additionally, if in a mountaineering situation in which you're tied in or roped up with your party members, it's important to understand that lightning can travel over wet ropes, and it might behoove you to untie from one another. Also, you want to discard metal objects. Place your ski poles and skis away from where you are sheltered, or discard them altogether. If you're in a water environment, very quickly you must exit the water and continue to try to exit the water until you are safely on shore. If you're on a boat, it's important to try to go below deck. If you're on a boat without a deck, it's important to tie yourself into the lifeline. This is because should you or the boat become struck by lightning and you take on an electrical charge and become unconscious, you won't fall into the water and drown. But what if you're outside and stuck in a lightning storm and can't find adequate shelter? The idea is that you want to keep looking and keep moving until you have no other options. If you've exhausted all other options, there is something called the lightning position. The Wilderness Medical Society states to do this if a strike is imminent. However, the National Weather Service does not support this and has not done so since 2008. First off, what is an imminent strike? How would you know this is occurring? Well, you might feel the hairs on your skin rising, you might have a blue haze around you, also known as St. Elmo's fire, and you may feel or hear crackling. The lightning position essentially occurs or is carried out by standing in some form of insulation, whether that's a rope coil, an empty backpack, or a sleeping pad. Once you've done that, you want to crouch down, touching your elbows to your knees, covering your head, and then sitting up on your toes and touching your heels together. The idea is that if a ground strike occurs and the current reaches you, it'll go up one foot, across the heels, and down the other foot. Likewise, if you should take on a direct strike, the current will pass, hopefully, down one arm, then touching the knee, it'll go down the leg and out the foot, thus avoiding the heart. Now, the National Weather Service says this provides no additional safety and instead urges you to continue looking for safer spaces. But most experts agree that if you've exhausted all other options for safety in a lightning strike environment, then you should consider the squat, knowing that it will likely do nothing to protect you. Now let's talk about the different types of lightning strikes or types of contact that can occur. A direct strike is just that. You are struck directly, either the object or you yourself. Contact injury occurs when an object that you are touching undergoes a lightning strike, such as if you're holding onto a flagpole and the flagpole is struck by lightning. Side splash occurs when the current jumps from an object onto you. So if you're standing next to a flagpole, not touching it, just standing next to it, and then the flagpole is struck by lightning, and then the current will jump from the flagpole onto you. Remember we said that lightning can jump about 15 feet, which is why you want to space out more than 20 feet during a lightning strike. Ground current is when an object or the ground directly is hit, and then that current continues to pass through the ground. If you happen to be standing within the radius of a ground current, you can then take on that current and sustain an electrical charge. This picture is from a golf course, and as you can see, in the center of that ferning area is where the direct strike occurred onto the ground, and then it became a ground current that spread out from that central radius, or central focus. This is an article in the newspaper relatively recently where 300 reindeer were killed in Norway, most likely from side splash that continued to pass from one animal to the next. If a person should sustain a lightning strike, there are generally three injury mechanisms at work. Concussive mechanisms generally incorporate barotrauma, blunt injury from being thrown during the strike, and shoulder dislocations that can occur due to severe muscle spasm. Electrical injury can cause neurologic, cardiovascular, dermatologic, and ocular injury, which we'll talk about more in the next portion of this presentation. And finally, there are thermal burns, which can cause injury to the skin directly. As I alluded earlier, in the next portion of this presentation, we'll talk more about the different types of injuries you can sustain and how to treat them.